Okay, hi. Our project is an overview on the performance of reasoning agents in large language models. And today, me and Nathan will be your presenters.
All right, so introduction. The rise in the usage of LLMs in both research and day-to-day life prompts the problem of maximizing efficiency in these models. And since they're largely limited to a one-dimensional model of decision making, the performance of LLMs is often impeded when it comes to tasks such as deriving context or arithmetic problem solving. As a lot of you know, ChatGPT often doesn't perform very well at solving math problems. And with the introduction of reasoning agents, including chain of thought reasoning or self-consistency, LLMs can adapt a more complex understanding of the context given to them and engage in a multi-step approach to solve a problem, which can often produce more accurate results for tasks such as arithmetic reasoning.
For our study, we took a multitude of reasoning agents that we found from reputed sources as well as previously published papers. And using these reasoning agents, we wanted to create a comparative study on how these reasoning agents would perform under the same conditions. Using multiple large language models, including those from the OpenAI as well as Meta's suite, we evaluated the performance of these reasoning agents through different data sets on both arithmetic and common sense reasoning. Using this and the results, we can analyze them to find which reasoning agents and LLMs work best for different tasks that can help improve the performance in different circumstances.
So currently our status is that we've tested most of the reasoning agents on Gemini for GSM-8K, which is a math dataset, and CSQA for common sense questions that involve reasoning, logical thinking. And we've tested base model, chain of thought, and auto chain of thought on Llama 2 for GSM-8K, the math dataset. And currently, we're still testing ChatGPT due to early billing struggles. But either way, this is a table of our results currently. As you can see, the first half section row is the results for the GSM-8K dataset, the math one. And as we can see, the AutoCOT or auto chain of thought reasoning has produced the highest accuracy when it comes to math problems with an accuracy of 80%. And for the CSQA dataset in the bottom half, we can see that self-consistency performs the best for these types of questions.
This is just a table of the Llama 2 tests that we've done. We have done tests on both the GSM-8K as well as the Common Sense QA dataset, but we haven't done full analysis on the Common Sense QA dataset yet, so we only have results for the GSM-8K dataset as of this moment. However, as you can see here, overall, the Llama 2 model performs significantly lower than the Gemini model would. And part of this is due to the fact that the Llama 2 model has fewer parameters. And however, we can see that Llama 2 does perform best using the auto chain of thought reasoning agent, which is the third reasoning agent being tested here.
So throughout our process of testing, we needed a few couple of steps for each reasoning agent. And the first step is always data preparation. Different reasoning agents require different amounts of data preparation. For instance, regular chain of thought reasoning just requires the text input question as well as an additional prompt at the end that says, let's think step by step to indicate the model to generate in a reasoning step-by-step process. However, AutoCOT or auto chain of thought reasoning, that requires a lot more data preparation, with us having to train our own clustering model to cluster different questions together for the model to generate different example questions for the prompt. And afterwards, we do a baseline test of the LLM. And then after that, we incorporate the reasoning agents such as chain of thought, auto chain of thought, and then we test that. And we tested on the GSM-8K dataset, and later we tested on the CSQA dataset. And then we compare the results for each reasoning agent on the dataset, as well as at the final end, arrive to a conclusion of which models and which reasoning agents perform the best for different tasks.
One of the first reasoning agents that we tested with our language models is chain of thought reasoning, which allows the large language model to reason out in a multi-step fashion. This is applicable in a variety of common sense reasoning prompts, and it increases the performance of the large language model by allowing it to think step by step, essentially in a certain sort of format, which allows the language model to spend more time as well as more computing ability to reason out its answers. There are three main forms of chain of thought reasoning, the first being few shot, where as part of your prompts, you would provide a few demo prompts as well as answers and how you got the answer. This allows the reasoning agent to sort of copy the format of the demo questions and answers, which allows it to improve its abilities. Going on from there, there's also one-shot chain of thought, essentially the same thing as few shot, but you're only giving one demo question and response. And finally, we have zero-shot chain of thought, which you don't give any examples, but instead you give the phrase, let's think step by step at the end.
The next reasoning agent that we tested is auto chain of thought, or AutoCot. And instead of just giving the model the prompt at the end that says, let's think step by step, the automatic chain of thought requires a classifying or clustering process beforehand that can cluster different types of questions into different categories. And the large language model generates its own prompts with example answers to example questions, in which those serve as the few shot for future generations. And these different example answers with paired with questions, these are given to the prompted to the model when different types of questions are given. For instance, if some math problems require calculus, or if others require like knowledge in finance, well, then those would be grouped into different clusters and therefore have their own generated example questions with answers that are double checked by us before we feed it to the model. And yes, similar prompts are grouped together. And yes, this is a outline of how the AutoCot works.
Another reasoning agent that we tested was self-consistency in chain of thought. This is a very good reasoning agent to use for multiple choice questions. Essentially what it does is that for each prompt that it is given, it reasons out as many different types of decisions and steps as possible. And all of these different decisions create a tree in which many different answers are generated. It then goes through all the answers and finds the most common answer and uses that as the answer that the final answer that the language model would then give to you.
So one of the models that we used is Llama 2. And the advantage of Llama 2 is that it's fully open source and free for research purposes, which means we also have access to the full model instead of like the other models like Gemini or ChatGPT that require an API to call the model. And Llama 2 has a lower token limit, which makes it sustainable for reasoning agents that require several calls to the model in order to perform a chain of thought. But it also has a smaller parameter size, which may indicate a drop in accuracy when it compares to reasoning tasks, such as compared to ChatGPT 3.5, as smaller parameter sizes results in less conditions to be thought about by the model. And currently we have amassed results of running automatic chain of thought on the Llama 2 model and are in the process of getting all of the other ones parsed as well.
Okay, another language model that we tested on was the Gemini-based model. This was trained on a variety of data, unlike most language models. So in this way, it's useful for generating very creative content, including poems or stories, and can also incorporate images or music into its responses. This is really good for building intelligent systems that can take multiple inputs. For example, you can use Gemini's abilities to create a language model or a chatbot that can also take audio or even video inputs. However, as part of a trade-off, this model sort of lacks more of that common sense reasoning that you can see in other language models. But the technical report for Gemini does indicate that it has high benchmarks for the GSM-8K, basically meaning it's good at doing basic arithmetic, but it also has very large computation requirements. And our test, the Gemini Pro base model, hit a 77% accuracy on the GSM-8K dataset.
So the other model that we tested is the most well-known one, ChatGPT 3.5, and its strengths include creativity, which mean it can generate songs or poems in many formats according to user requests, and it's also good at conversations, which means it's better equipped for conversing with humans like me and you. And better performance, it has also a better performance with common sense reasoning. And the ChatGPT 3.5 Turbo model currently achieves around a 75.3% accuracy on GSM-8K without any reasoning agents, which means this is the base performance of the model. But however, some of the limitations include that it was trained up to January 2022, which means if new research discoveries have been made, or new research discoveries have been made, then if you ask ChatGPT about it, it won't really be able to answer according to that, and it may just hallucinate and make something up. Also, it has less accuracy than the newer models, including ChatGPT 4, which in the future we also plan to test.
For our future plans, we plan on finishing testing on our datasets as well as our language models. And we also plan on expanding to datasets that are more similar to the common sense Q&A to have a better understanding of the common sense and reasoning abilities of each language model. We find that examining both the common sense reasoning as well as the arithmetic reasoning should produce a more accurate evaluation of the performance of reasoning agents in a general metric. We also plan on expanding the study to include several other reasoning agents, including React and reflection. We plan on, in the far future, after we're finished with our testing, using what we've learned about different reasoning agents to create our own reasoning agent that is trained and tested to perform very highly in a certain scenario.
And these are the sources that we used.
For our acknowledgements, we would like to thank Dr. Mui, Dr. McMahon, and Mr. Subramaniam for helping us kickstart this project and provide us helpful advice along the way as help us make significant progress. And we would also like to thank ASDRP for providing us with the opportunity to do this research.
Thank you for listening. Oh, if you have any questions, feel free to ask.
Yeah, excellent job, guys. That is a good summary.